Alright, welcome back to Fat Mama Physics. In this video, we're going to look into something called acceleration. This video, I'm going to break it down into two parts. The first part, I'm just going to talk about, give you an introduction on acceleration with the PhET simulation, The Moving Man. And I'm going to use that again in the second part where we will be looking at examples of how acceleration can affect your motion. So part one is just this introduction here. So acceleration, we've talked about it before, we've seen velocity change. The definition of acceleration is the change in velocity over the change in time. Or in other words, the rate of which velocity changes. Another sign that a sign that we use for change is this little delta sign that looks like that's like that. And you will see that more often later. And oftentimes when we talk about change in physics and in physical quantities, okay, over the change in time. So we're talking about a specific point in an object's motion where we will examine the acceleration. So if we break it down, so what is a change in velocity? How do we define change? Change in velocity, by definition, is the final velocity minus the initial velocity. All of that divided by time. So if we put that into symbol format, it looks like this. On your data booklet, final velocity is represented by a v. I like to put a little arrow on top to show it's a vector, minus u, which symbolizes for initial velocity, all of that over time. Now you may see, you might watch other YouTube videos, or you might look at other sources, and the notation might look a little bit different. And I'm going to put that in brackets on the side, where you might see VF to signify final, minus VI to signify that it's initial. And for us, I would prefer us to use U and V because that's directly from the IB data booklet, and which is the symbol that we want to communicate with. Okay, so what are the units? Now, if you take a look at the top, I'm going to rewrite this again. Notice at the top we have meters per seconds, and it's divided by seconds. So the units, if we take meters per seconds divided by seconds again, we get meters per seconds squared for the units of acceleration. Okay, so what that kind of means is you might think that, or some of you might think that does this mean that every second I gain 1 meters per second for speed? Every second I gain, so for example, if I start off at 0 meters per second, and let's say my acceleration is 1 meters per second squared, does it mean that after 1 second, I am now at 1 meters per second? So after 1 second I am now traveling at 1 meters per second. Then the next second, I'm traveling at 2 meters per second. Yes, you're kind of right in that sense, but we need to be very careful about one thing. Oopsies. And that is, during the time in which you accelerate, you are also gaining speed. So here you might see you might be 1.1, and then here you might be 0. Sorry, did I say 1.1? You might be 0.1 and 0.2, 0.3, and all the way up to 1 meters per second. So you're constantly gaining speed within that 1 second. So that's something we have to be careful of, is even between that second, within that second, you're gaining speed. Okay. You might even think of it as in you're gaining speed even per millisecond, even every microsecond, even smaller than that. In terms of the time increment, you're still gaining speed. Okay, so let's take a look at what I mean, and we're going to jump right into the simulation. So if I put this man all the way at the very end, and I put him at at acceleration of 1 meters per second, it's not 10. We play, and notice that during the time in which he accelerates, every 0.1 of a second, and if this simulation can record down to the milli, the micro, the nanosecond, you will see him constantly gaining some bits of velocity here. Okay, so notice that as he was accelerating, this velocity here was constantly changing. Okay, so that's acceleration. You're gaining velocity over time, or you're losing velocity over time for that matter. So we'll take a look at this example. Oh hey, I just paused it right here. Okay, let's take that. So let's do an example with the equation above, and I just started him at 0 meters per second to begin with. So let's do an example with his initial velocity was 0 meters per second. His final velocity is, which I paused in, 5.625 meters per second. And then the time here is 5.6 seconds, as what it shows us on the simulation. And let's do a quick calculation to show you what it looks like. So acceleration, final minus initial over time. His final is 5.625 meters per second minus 0 divided by 5.6. And let's calculate this one out. 5.625 minus 0, that's just 0. And then divided by 5.6. We get something that's 1.00, which rounds up to 1.0 meters per second squared. Oops, I forgot my units. So that's what now you might be wondering, oh hey, there's it's not exactly 1, and yes, you're right. If this time here could have been recorded down to a few more digits, significant figures, perhaps we would get a closer value to 1. Okay, so that's how you would use it. Now, majority of the time, we'll be dealing with something called constant acceleration, which means that the acceleration does not change. Now, if it did change, it would be very complex, and I don't expect you to be able to do those kind of problems. In the one motion, okay? But take a look. So, for example, he traveled at 1 meters per second for this entire trip. It is constant. It did not change. He gained velocity at a constant rate, at a constant acceleration. So what does it mean for the acceleration to be negative? We've dealt with positive acceleration, and yes, you're right, because acceleration is dealing with vectors here. Yes, acceleration is a vector. So, since acceleration is a vector, it does have direction, and whenever you report out or you communicate acceleration, you need to tell the direction. But what does it mean for acceleration to be negative? So let's put our man in the middle, because we have no idea what acceleration is. Let's set his velocity as 0. Let's clear the screen. I'm going to put that at -1 acceleration, okay? So a -1, let's see what he does. Play. Oh, hey, he's going backwards. He's accelerating in the backwards direction, gaining speed going backwards. So it shows that this man is, I'm going to write that down, gaining speed in the negative direction. So that just shows that the negative acceleration does not necessarily mean somebody is slowing down, okay? And in the next video, we're going to look more at cases of when is the moving man speeding up, slowing down, in what cases, what scenarios, given if its initial velocity and acceleration are positive, negative, 0, etc. Okay, so we're going to look more into what it means. But for now, what I want you to know from this example is that if he has a negative acceleration, every second he is gaining speed in the negative direction, okay? And this negative direction is something arbitrary in which we determine in our problem and how we dictate that ourselves, okay? So please tune in into part 2 of acceleration, in which we will look at all the different scenarios of when an object is slowing up or slowing down. Great! I will see you on the next video. Fat Mama Physics signing out.